Hello everybody and welcome to the webinar number 12 in the Open Discovery Space series. This webinar is entitled Metadata Ingestion in ODS. This webinar aims at introducing the concept of harvesting as well as the protocols and technologies related to harvesting in ODS. After this module, learners will understand and be familiar with metadata harvesting. They will know and be able to implement the OAI PMH protocol in their repositories and will be able to implement and make public their collections through an ONI PMH endpoint. The speaker will be Enayat Rajabi. He's a researcher and PhD candidate at University of Alcalá. He's coordinating University of Alcalá works at ODS Working Package 7, which includes everything related to harvesting and other content integration tasks in ODS. Now I hand it over to Enayat. Enayat, please go ahead with your presentation.
Okay, thanks, Roberto. This webinar is about the metadata ingestion in ODS. So it's supposed that we are discussing here about how we could harvest the metadata ingestion in ODS, how we could integrate this metadata, clean it, and afterwards how we imported this metadata in the ODS portal. So first of all, we have a brief discussion about the repositories, what is the federation, and what's the harvesting is going to be done in ODS, and the protocol that we used for harvesting, and the implementation and the tools of these protocol. And the next step, we discuss about metadata aggregation steps, including the filtering, transformation of the metadata so that metadata were cleaned to be imported into the ODS portal. And finally, we have a brief discussion over the next module that we will have in this webinar. Okay. At the first glance, I want to show you the steps that we did to import the metadata from the ODS partners repositories into the ODS portal. In these steps, as you can see, the first step is harvesting, collecting the metadata, and the next step is transformation and identification of the metadata. After that, we will have the validation step. We will validate metadata against the ODS application profile that we discussed in the previous webinars. And after filtering and language enrichment and link checking the metadata elements, we have the metadata ingestion that we import the metadata into ODS portal. So first of all, we start with harvesting. So in the harvesting, there are several words that we can discuss about that. The first is federation. So what is the federation? Federation is a decentralized approach for sharing and collecting the metadata from several repositories through the harvesting protocol, for example, the OAI PMH target. Through a federation can suppose interoperability among the repositories that it harvests. So, in other terms, we can say that federation refers to the fact that metadata information are collected from many data providers and publishers to create one repository including all the metadata. But how the federation collects the metadata is the matter of the way that we harvest. So the harvesting refers to this fact that how we can collect and aggregate the metadata from several repositories um, in, for example, ODS. So the way of collecting and aggregating metadata through several repositories, we call it harvesting. That can be done through incremental harvesting or full harvesting or other methods that we have in the, for example, ODS project. Now you can see a figure in which we show the different repositories and a federated repository that a user can reach through the metadata from a portal or a website that is connected to the federated repository. This federated repository, as you can see, harvests several repositories and finally present these metadata to a portal or other interfaces. But how we can harvest? One of the methods is OAP-Image protocol that allows repositories to present their metadata, their XML files to be harvested by service providers. OAP-Image is a metadata harvesting protocol, and almost 75% of the repositories have this interface and use this interface, and it consists of several verbs for communicating between the server providers and the data providers. Okay. I want to show you the next slide. Here is about the OAP-Image target from the technical perspective. Okay. Roberto, can you
Okay.
see the slide 10? Because
Yes, it is entitled OAI PMH Protocol Basics, other
yeah,
harvesting
because I
protocols.
lose the PDF here. Okay. So the OAP-Image protocol basics is the next slide that we want to talk here. This is the one of the protocols for the metadata harvesting. Another protocol is RSS or other kinds of API that we have, for example, Atom or REST. That not all of them is for the harvesting, but programmers use some of these protocol and application for scraping or collecting metadata from the data providers. Through the OAP-Image, target data provider can expose and publish their metadata through 6 verbs that OAP-Image target provides. For example, identify of the target, list of the metadata formats that may have one data provider, list of sets that we will discuss later. So these 6 verbs are part of the OAP-Image protocol. So to allow various repository configuration, OAP-Image target represent data in 3 entities: resource, item, and record. So the data that we want to expose is called the resource here, and for each resource we may have some items and some metadata, and for each metadata we may have different types of record and schema. For example, here you can see that this painting is a resource. but it can have many metadata here, and each metadata may represent in different formats. For example, in Dublin Core, or for example, IEEE law and other metadata formats. So resource refers to the object, and item refers to the information about the resource, and metadata with the specific schema is placed in the record. So any record in the OAP image target may have several parts. The first is header, and the second is metadata, and the last is some optional elements. For example, in a header, you can put the identifier or data stamp, or some status information about the record. For example, if your metadata is updated at the specific date, the data stamp can be placed in the header. The metadata itself is the main part of the record, which includes XML files, including the elements, information about the metadata, and some information about the publishers. And record has another element which calls about optional elements, that the data provider can provide some information about the copyrights, about the provenance information about the metadata, and other optional information here. For example, here the data stamp. What's the point of the data stamps here? And the data stamp refers to the date, the last date of the last date of the modification of a metadata record, which means that if, for example, you updated your metadata today, the data stamp for this record will be placed today, and it's very good for the incremental harvesting because sometimes data providers want to expose their data from specific days or dates. So it's very good to have, for example, data stamps. Another application of data stamp is for delete records. So if you implement the OAPMH correctly, you can specify these data stamps, and you can provide this information about the deleted or updated date of the metadata, so that a service provider can harvest the metadata as well. So another part of the OAP image target is metadata schema. When you want to expose and publish your metadata, you should provide your metadata in a specific schema. For example, Dublin Core or IEEE LAM. So this schema specifies the identifier of the metadata and a URL to the namespace of the metadata schema, and some information about the major schema that these metadata should be complied. For example, in our example, the ODS application profile is provided somewhere, and the information about this metadata schema should be placed in the metadata for the validation step. Another part of the OAPMH is sets. Sets are the logical categorization of the metadata. So you can group your metadata and divide your metadata through some sets. For example, from the subjects of your metadata, or about the date of your metadata. So through these sets, a data provider can publish each set that they want. For example, about the several metadata in this year can provide according to the dates, or if the data provider wants to publish the metadata according to its type, it can divide it to theses, books, or audios, and can expose the metadata through OAP-Image target according to this type of sets. The basic functionality of OAP-Image target is based on HTTP protocol. As you know, the HTTP protocol includes the gets and post parameters. So through the webs of OAP-Image target, two data provider and service provider can communicate together, and they can respond to each request, or they can provide some error message according to HTTP protocol. For example, we have the list of the verbs for OAP-Image target here. For example, identify, which returns information about the repository, what's the repository, who is publishing this metadata, what is the technical information about the data publisher. Another verb of OAP-Image target is about list metadata formats, which includes a list of the metadata schema and formats that a data publisher uses. Or list sets includes a set of categories and groups that a data publisher is using. Or list of the identifier includes list of the record identifiers or dates or other header information of the metadata records. And another verb which is very popular and can be used by the data publisher is list records, which are metadata records from the repository. So if I use this, for example, I use these list records in a OAP-Image target, I can see the list of the records and metadata of the target repository. And the get record is similar to list record, but it gets an individual metadata from the OAP-Image target. Here you can see the technical aspect, another technical aspect of the OAP-Image target, which shows that here a service provider or harvester can harvest several OAP-Image targets. With this target is provided information of metadata by the data provider, and each time can get the information by each of them. For example, can get information about the list set from this repository or this repository, and so on. This part of the communication between the service provider and data provider can be through a flow control, and it depends on the policy of the data provider. For example, some of the data provider can expose the a specific amount of the metadata. For example, 100 metadata records. If the data provider provides such restrictions or limitation over the metadata record, a service provider can request only this amount of data. For example, as you can see here, first the service provider wants to have all of the metadata, but the answer of the data provider is only 100, and afterwards a resumption token is exchanged between these two partners, and finally the data provider, for example, according to its policy, represent all of the metadata to the service provider as well. So what's the requirement as a data provider? If I have a repository, what should I do to expose and publish my metadata? The first of all, the data publisher should prepare its metadata and the data as a schema. For example, provide its metadata about the books in the Dublin core and validate these metadata schema. And afterwards, it can provide its information into the sets, logical sets, and categorize its information and identify those service providers that want to harvest the metadata. And apart from that, it should provide policy so that the service provider knows how to harvest its metadata. So as I mentioned, metadata about the resource should be provided by the data provider. These OAP image targets should be accessible and available through a web server. A unique identifier should be assigned to each metadata in each item, and using some programming interface and some tools, this information should be provided and should support the OAP image target as well. And as we mentioned, the metadata format should be defined in the OAP image target. Okay, let's go to next slide. After all, and after knowing about this protocol, the data provider can use some of the online tools or some specific tools that they can provide from this URL that exists here, and the data provider can install the tools and provide the metadata in the tools according to the format of the tools. For example, if the tools is provided to the database, for example, some metadata can be provided in the database, and some tools can be installed on top of the database and expose the data through the database as well. But some of the tools get the information through the file system. So according to the tools, data provider can publish their data. In this URL, you can find some information like this, a list of the OAP image target tools that each data provider can install one of the tools and can provide the information and import their metadata files into the tools as well. In our case, we used Ariadne as a harvester, and Ariadne has another tool for as a repository and provide the metadata as OAP image target. So Ariadne can be another tool for this case. So after discussing the harvesting process and what we should prepare for the harvesting through the OAP image target, we follow other steps for importing and ingesting the metadata into the ODS portal. So in the ODS, through a software that I mentioned, Ariadne, we could harvest several repositories, and we aggregated this information into the ODS repository. So first of all, we provided the ODS application profile for repositories, and we presented this ODS application profile to them so that they are aware of the type of conversion that they should do for transforming the metadata to the ODS application profile. In a specific, the ODS application profile is according to IEEE law. But for example, in some cases, the ODS repositories may have other formats, for example, Dublin core. Having these ODS application profile, they should know that what are the, for example, mandatory elements and how they should provide for us the mapping between their schema, the source schema, to the target schema. So the next level is transformation. In the transformation step, we want to transform the repository metadata to the ODS application profile. So what we need from the ODS repositories is providing a XSLT file that we discussed in the previous webinar, so that we can map automatically the source schema to the target schema. For example, if the one of the ODS repositories provides its metadata in Dublin core, it should provide a XSLT file, a mapping file, to tell us that, okay, for example, the title of the, for example, my metadata is in this term, for example, title, that should be mapped to the IEEE LUM, for example, general title or something like that. Or, for example, my vocabulary as an ODS repository here is categorized to, for example, these 5 vocabulary, and this should be mapped to the ODS application profile vocabularies as well. So here we requested the XSLT file from the ODS repository, and having these XSLT files, the transformer can get the actual XML files, can use this XSLT file from the repositories, and can use the ODS application profile here and create and generate the final XML files. These final XML files will be the target, and the final XML files that should be according to the ODS application profile. Some repositories had another schema apart from IEEE LUM, so we had this problem in the procedure, and we requested them to provide exactly the XSLT file so that we can import their metadata into the ODS repository. The next step after the transformation, we have the we supposed to have the correct metadata from the repository. So the metadata should be identified in the ODS repository. Each metadata has its own identifier. For example, if we have the repository A, it has its own identifier. Repository B has its own identifier, but maybe they have some conflicts, and the identifiers may be repetitive in the ODS repository. That's why we assign an identifier to each metadata record, so that each metadata of the repositories can be identified in whole ODS repository as well. So in this step, we use the routine, and we use the algorithm to specify an identifier to each metadata in whole ODS repository as well. The next step is validation step. When the metadata pass the identification step, we should validate the metadata with the ODS application profile. In this step, we check everything against the ODS application profile. For example, if there are some metadata elements absent, we communicate with the repositories to provide the correct XSLT file and to provide this metadata, so that we can import these metadata correctly into ODS repository. Or, for example, there are some incorrect vocabulary in the source file, so we cannot validate it against ODS application profile. There is a vocabulary that does not exist in the ODS application profile. That's why some of the metadata are filtered out in this step, because they are not valid against ODS application profile, or some of them um, uh, are not respected to the sequence of the element. For example, they put some elements in the wrong order, so we cannot validate these metadata as well. Because, for example, sequence rules in the ODS application profile should be respected so that we can import it into the portal. So now in this step we have the validated metadata records. Having these validated metadata, we should have some tests and checking for filtering out those metadata that have wrong value in the mandatory elements. In the ODS application profile, as we mentioned, we have two mandatory elements. The first one is the title, and the second one is the technical location of the metadata, which points to the actual address of the learning object. So if the title of the metadata is null, or the actual address of the learning object is not reachable, we cannot import it in the ODS portal, because we are indexing the information in the ODS portal according to the title, or user wants to click on the actual address of the learning object and points to the actual data on the web. But if there is some invalid URL or invalid title, the user fails to follow the metadata in the ODS portal. In this step, we filter out the empty titles and empty or malformed URL, so that in the next step we should have some correct, let's say, titles and correct URL format. In this step, it should be noted that in this step we don't check the URL as a valid URL address or valid URI. We check the technical location here, that it shouldn't be empty, for example. The next step is a language enrichment. Language is very important for some of the elements of metadata. For example, in title and description, because specifically these two elements should be indexed and should be filtered in the search, for example, the search part of the portal. So if a title or description lacks of the language, we cannot search the title according to the language, because language of the portal is one of the features that user can select and can be directed to the search results according to this filtering. So we had to put this step after the filtering step, so that we can enrich the some of the metadata elements with language. So here we use some online tools or language detector tools, so that we can recognize the language of the title automatically and put the language attribute for example, title or description of the metadata. The last step before the importing the metadata into the ODS portal is link checking. Maybe data provider provides a link, a URL in the technical location, but technically this URL is not reachable. For example, it has some timeout problem or it's a broken link. So having this step helps a lot to avoid having broken links in the ODS portal. Um, with some techniques here, we get the technical location of the metadata, we check its accessibility and availability, and finally, if this address is reachable and available, and it doesn't have the timeout problem, we pass it over this step, and the metadata can be imported to the portal as well. Here you can see the procedure that we followed for the link checking. For example, after harvesting and having all these steps of aggregation, we check the technical location, and we um, check we check the link and technical location of metadata. If it's broken, we put it in the database, and periodically we check the broken links so that, for example, in next harvesting cycle we could have the fresh metadata records in the ODS portal. The last step of metadata ingestion into the ODS portal is importing of the metadata records through a tool called Updater. So metadata, the XML files specifically, passed several steps, including filtering, link checking, and finally we have the clean data. So in this step, we read each metadata records, and we imported these metadata records into the database so that the data can be available through the interface and portal, and that reads from the database. So this tool reads the metadata and XML files one by one and import it into the database. Something that should be noted here is when we have the harvesting cycle, in each time new data is replacing the previous by the new one. So because the metadata is owned by the data provider, so we don't add any information or checking something different between the previous metadata by the new data. So we simply replace the previous metadata with the new one, so that we can have fresh metadata into the ODS portal as well. So something that I mentioned here is the ingestion of the metadata into the ODS. As your practice, you can provide some XML files. You can publish your metadata in any format that you want as a test using the tools that I mentioned through OAP-Image target. Provide your information, provide the data stamps, provide the identifiers, for example, information about your repositories, and you can implement it, and you can expose them through this protocol as well. And by installing some other harvester, for example, Ariadne harvester, which is very simple, you can harvest and aggregate these OAP-Image target that you have developed, and you can check that if everything okay through the OAP image target as well. Because when you provide all your metadata through OAP image target, your metadata will be available through a URL, and you can enter this URL into the harvester, and then the harvester um, starts to harvest and aggregate your metadata and insert this metadata into a file system, um, into the repository. And you can test the sets, you can divide your information and metadata into the sets, and you can expose a part of your metadata into OVP image target, and you can test as well. So this is a very brief discussion about the ingestion and the steps that we followed for importing the metadata into the ODS portal. The next module is about the content alignment and harvesting methodology and workflow that we followed for harvesting metadata into the ODS project. In the next module, we explain the procedure that we followed for aggregating in several phases. We will mention the roles and responsibility of the harvesting, the list of the responsibilities that projects should consider for harvesting a step. And we will describe the content integration scenarios that can be happen, that can be discussed not only in the ODS project, but also in any project that has these aggregation steps inside. Okay, this is the explanation of the ODS ingestion, ODS metadata ingestion, and how we could elaborate and how we could import the metadata records from an ODS partner to the ODS portal. Hope it is helpful for you. If you have any question, please don't hesitate to ask.
Thank you, Enayat, for your presentation. While we are waiting for some questions from the audience, I have one for you. You spoke about a tool for enriching language through automatic language detection. What's your opinion about this kind of tools? Are they good enough? Can we rely on them?
Totally, overall, yes, we can rely on some automatic language detectors for detecting the language of for example, small parts of metadata. For example, here we use the language detector for title and the description of data, but it used very good, and we could detect the language of the text in our harvesting step. Although we used only for 2 or 3 repositories, because apart from 2 or 3 repositories, other provided the language attribute, but we limited this language enrichment for those repository that had this problem. But for those repository, the language detection performed very good, because the language detector could detect, for example, here the Russian, for example, language for the title and description, and I recommend to use this kind of language detector tool.
Thank you for your answer. I have another question. What software do you use for link checking?
Link checking, we use the a Java program to check the URL response code simply. So this program link checker exists on GitHub, and I can provide a link for you. So simply we get this value of the technical location in the metadata and checks the response code and checks the, for example, if the URL uses some secure protocol like HTTPS or not, or some, for example, timeout problem or not. We checks all of these issues, and we get the response code, and if it has some timeout problem or it's broken, we filter out this URL from our list.
Okay, thank you. It seems there are no questions from the audience, so we can now finish the webinar. Do you agree?
Yeah. Thank you very much.
Okay, so thank you, Enayat, for your interesting presentation. Thank you, everybody, for your attendance. Please remember that you can replay the webinar at any time on YouTube. Thank you for joining us, and have a great rest of the day. Bye-bye.
Bye.